Hi, good morning, everyone.
Morning.
Today is 17th August, Saturday at 11 a.m. We are starting our 180th webinar in NFE. So, welcome to National Federation of Engineers for Electrical Safety's webinar. And most of you are aware of NFE. This society was born just 18 months back. And in these 18 months, a lot of records were broken. When I say records were broken is, we have done 24 physical seminars, traveling length and breadth of this country, BAS being our partner in creating an awareness. So we are traveling across the country and talking about National Electrical Code of India with regard to electrical safety. Apart from conducting seminars, we are also, I said, 180th webinar. So overall, over 50,000 people have been watching our webinars, and we are meeting them individually and across the country. So that is the way we can create the awareness on electrical safety. If you look at just 18 months before, there was not many organization or a society, a non-profit society was talking about this. We have taken this with a lot of commitment that we will create electrically safe nation. So we are fighting for today for better tomorrow through our next generation. And what is our mission, our vision? Vision is to make every electrical installation free from accident and electrocution. Mission is we shall strive to achieve our vision through getting accredited for products and personal certification. We shall focus on electrical safety by design, manufacturing, installation and maintenance of electrical product, and installation by competent and qualified manpower using quality resources, including product, process, and procedure. This is a clear mission of NFE. So what we do, we already explained. We are going length and breadth of the country. We are starting certification program, which you'll be seeing shortly. And why you should become part of this whole movement called NFE. It's a very simple, it's just 1,000 rupees annual fee that we are talking to for each individuals. And corporates, it's 5,000 rupees an annual. And MSME, 2,500 rupees. It's nothing when it comes to the kind of knowledge that we have been sharing across various platforms. And if you see, every month we are doing 4 to 5 webinars. Average attendees of each webinar is over 300 people. You can even 300 into 4. That's a volume of people that we touch upon every month. And we recently, just last 20th July, we spoke about occupational health and safety audit, code of practices that by our Mumbai chapter president did that. Then we spoke about electrical safety in healthcare segment. Then we had power quality measurement within the industry. Aribala did that in the last Saturday. And today is a very special day, independent gift to all our members who joined. That's from Mr. Dr. M.V. Chilkuri, very active member in NFE, and he's a very proud member of NFE, highly technical personality. And he's going to talk about harmonics and switching transient analysis as per IEC TS 63222, 1 and 2 and 100. So let's see what power quality monitoring our Dr. M.E. Chilukuri will talk on this. And just to introduce myself, I'm one of the founder member of NFE with fire background with over 35 years. I've been in the fire industry and being part of many association that is born in India. I would like to introduce our speaker for the day, Mr. Dr. M.V. Chilukuri. So he is holding a degree in electrical and electronic engineering and a PhD in electrical engineering. Served as a lecturer in Multimedia University, Malaysia, and as an assistant professor at University of Nottingham, Malaysia campus. He is now associate professor at Vellore Institute of Technology, University, focusing on power system and smart grid. With expertise in power quality and green ICT, he is actively engaged in IEEE and CIRED, promoting smart grid technology and research initiative for smart communities in India. He is very active in almost all the forum, and his mission is very clear that the awareness and power quality need to reach every citizens of this country. And I now welcome Dr. M.E. Chilukuri to take this webinar forward. And this is going to be a 45 minutes webinar. I request everyone to post your questions. We have a Q&A box. If you look at below your menu, there are menu Q&A box. Please put all your questions in that Q&A box. If you put it in chat box, that will not go on record. And our speaker, Dr. Chilukuri, will not be able to read from the chat box. So I urge you to post your questions only in Q&A box. Then once our speaker completes his presentation, we'll take on question and answer. Over to you, sir. Welcome. Good morning once again to you, sir.
Good morning, Mr. Dominic, and thank you, everyone. And I would like to thank and appreciate NFE for this initiative. And also, I'd like to appreciate the participants for their time to join this very important topic, power quality, especially referring to the IEC 63222. And it has several parts. I will briefly touch all of them and highlighting the importance of measurement related to power quality, harmonics, and transient. Okay, let me share my screen now. Hope everybody can see my screen now.
Yeah. Yes, go ahead.
Okay, so this is my presentation. I hope everybody can see it, actually.
Yes, go ahead, sir.
Okay. How to move this? Okay, so let me introduce you briefly that, my background to everyone. Okay. Before that, okay. So tell people something they know already and they will thank you for it. If you tell something new, people hate actually. So that's what George Monbiot said a long time ago. He is a journalist and he is a climate change activist. And today I'm going to tell some important things for you, which you may not have found in any standards or textbook. Okay. And you'll be glad to know these things and you'll be glad to attend this seminar as well. Power quality is nothing but corruption of voltage supply resulting in financial losses to the customer. So that is my definition on 2024. Okay. I will give you another definition. Perhaps these two definitions will come in the textbook that I'm planning to write, actually. Power quality also defines the quality of infrastructure, business, and processes in the digital world. So this is very, very important definition that you will not find any IEC or IEEE or any national standard. And I'm defining today that power quality will tell how a country's infrastructure, business, and processes will work effectively and efficiently in digital world. And every country is trying to become digital, going through digital transformation. So in that context, you should understand power quality. And power quality is not restricted for only power quality experts or electrical engineers or students. Many people think that this seminar is for students. Not at all. This is for everyone and everybody should attend it. Okay, so this is my two definitions on power quality today. So let me give you a brief, background of my, experience in this domain. I have published 17 publications only on power quality in the last 24 years, and it includes two tutorials conducted at international events, one in 2004, long time ago, and two workshops. I have conducted workshop for industry, and I have conducted a workshop for, government people. Then I have delivered two keynote speeches and 5 seminars. And today is a second webinar, not first webinar, second webinar. So these are the brief outline. And the first paper on power quality published in 2001 in CBIP conference. And next in CIRET 2002, which is an international conference on electrical distribution. Then we published in IAA conference. Then I conducted a first workshop on power quality for industry along with Schneider Electric. This is a very interesting workshop conducted in 2003, that is 2 decades ago, including the demonstration of harmonics. The Schneider Electric Singapore has built a harmonic monitoring and measurement system specifically for this workshop way back in 2003. And there was one speaker from the Schneider and myself. We are the two people who presented this workshop to Institution of Engineers Malaysia, who consists of many engineers from industry and academia attended this. This is a full house workshop conducted in 2003 for Schneider Electric in collaboration with Schneider Electric Singapore. Then I have presented papers in IEEE 10Con 2003-24 and published in IEEE Transaction on Power Delivery, IEEE Transaction on Instrumentation and Measurement, and also on industry conference on emerging power supplies in Malaysia, and the Asia Power conference on conference and exhibition on power quality CIRET, and also on international conference on instrumentation measurement technology in Singapore. This is a very important conference because it's on instrumentation and measurement, where we presented the first prototype of real-time power quality monitoring system developed way back in 2006. Okay, and many such conferences were conducted, and we have written one article for the Asia Power Quality Initiative, APQI, and also to the last one I will tell you, we have written an article on power quality even for Society of Energy Efficiency Managers, SEAM, in 2019. It was published in December. And these are all the technical contributions from my side in the last 25 years. Okay. So you can have a look at it. If you want to know basics of power quality, I have conducted these webinars for IEEE Smart Grid. This is slightly different than power quality, highlighting another topic, but I have also conducted seminar on power quality in smart grid for IEEE in 2001 during COVID time. These are all available on demand. Perhaps you have to pay 15 USD to attend. So those who are attending today's seminar or webinar free, of course, you have to consider yourself lucky, because none of these things are all freely available for anyone. If you want to gain knowledge, you have to put money. Okay, so this is the minimum you can put up to attend any technical seminar, which is very useful and knowledgeable. Okay, and IEEE, Smart Grid provides this free access, to the members, but non-members have to pay 15 USD to attend this. Anyway, so this is the conference where we presented our first prototype of real-time power quality monitoring system. It's not published in any normal conference. It is published in IEEE Instrumentation and Measurement, where people with highly knowledge in instrumentation and measurement will come and attend and publish any innovative solutions and products. So this was our first contribution especially in the power quality domain, as we developed a real-time remote power quality monitoring system and successfully started verified, measured harmonics coming from the variable speed drive. In fact, the variable speed drive was developed by Schneider Electric along in collaboration with Multimedia University. And you can refer this article to know more about what is the research contribution and industry contribution from my side. And I highlighted the need for power quality monitoring in India in 2001 itself, 2021 itself in this article. If you just talk about IoT, AI, and machine learning, data analytics, that's not going to be any benefit for anybody. People need to know, power quality at various cities and industries so that it can be improved. Okay, let me come back to very quickly on what is IEC TS 6322. If you have attended the last week's seminar, it is on IEC TS 63191. So 63191 is on power quality, demand side power quality management, but 63222 is actually on various other aspects of power quality. So if you see that it has several parts. It has these 4 parts plus one more part is there. Okay, the first part is on general guideline, and you can see this was published in 2021. And it is 85 pages voluminous document. Then second part consists of power quality monitoring system. And this was published recently, 2023, and consists of only 30 pages. Okay. Then part 3, it is on characteristic modeling, especially characteristic modeling of the customers. And it is very, very important for harmonic analysis. And it was published in 2024, and it is 38 pages. Now, the last one, part 4, is harmonic analysis over public supply network. This was also published in 2024, and it contains 46 pages. Now, what is the importance of this 4 document? If you look at this 4 document, the first 2 or 3 already published, and the 4th one actually is on voting. Right now, 4th one is on comment, and the 3rd one is on voting. So already 1 and 2 are published, and you cannot do anything. If you want to, do voting, and I think the voting can be done for Harmonic or public supply network, provided you have expertise and you have gone through it, and if you want to suggest any recommendation, that you can do, because that the deadline is 13 September. You can see here. Similarly, this was open for comment, but it's already closed because the date is 3rd August 24. It's already elapsed. So those who are involved in power quality and those who are not also involved, but they are using the standard, they should be in a position to comment, give suggestions, and vote. Otherwise, our contribution to the technical domain, especially at the international level, will be zero. Okay, but not many people in India are able to participate and contribute technically at international level, especially in power quality. Anyway, so let me give you just a brief outline of what is power quality. And here you can see in this diagram, and you will find this diagram also in the National Electric Code 2023, and showing this the variations of power quality events. We call it as power quality signature. You have here the voltage dip, slow voltage variation, fast voltage variation, short interruption, long interruption, then flicker. You can see here the left-hand side are short interruptions and steady state, and the middle comes the flicker, which is the low frequency harmonic, and then high frequency harmonics are harmonics, and very high frequency are considered supraharmonics. That is still not here in this picture. And then last one is the transients. So these transients can be of very short duration or very medium duration. Short duration because of lightning will be order of megahertz, okay, or few hundred kilohertz, and medium duration are due to switching. Okay, a switching transient is the major problem that I will highlight in my presentation with a case study. And lightning over voltages are lightning transients are not very high in India compared to Singapore or Malaysia. Okay. Now, you have seen the only power quality signature. There are many ways of looking at these power quality signatures in time domain. The time domain, the previous slide actually shows how the standard defines them. Standard always defines them in terms of RMS value. But every equipment actually works on the instantaneous value that is shown here. Okay. So here in this slide, we are showing both instantaneous and RMS variation of the same power quality event. Of course, how we are able to, this is what my research background. I have been working on power quality signal processing since 2000 and have published many papers in international conference in, and also written article for IEEE transaction. So the next one is the advanced power quality analysis, where we actually show the power quality event both in time domain and frequency domain. The reason being, this time frequency domain characteristic of power quality will be very useful in diagnosis. But tell you, this is a 20-year-old research, but still not even a single country actually has tried and explored an implementation of this in any electrical equipment. Only one or two people who can do is myself or somebody who has done research in this area. Okay. Of course, we don't do anything, or develop any product unless industry or government funds that. Okay. And industry and governments are many years behind, academics in terms of, vision and mission and understanding the importance of power quality. Okay. Anyway, so what is power quality management? It looks like a very new word to everyone. Okay. And last week, you have attended a demand side power quality management. But before you know demand side power quality management, first you should understand what is power quality management. Okay. So here, I'm not actually showing what is there in IEC TS 632. I'm telling what I feel and what it should be there in IEC TS 632. Okay, from my expertise, my perspective as an academic, as a researcher, as a consumer also. Okay, so first thing in power quality management is power quality monitoring should be there, not 1 week or at one location. No, power quality monitoring should be continuous and 365 days, 24/7. In fact, that I have mentioned this to CEA during our presentation on, transformers failures at SPV plants. And I have also suggested Grid India for considering continuous power quality monitoring at all the renewable energy plants. And they have agreed. I'm not sure whether they have implemented and come up with a policy and shared that with the various stakeholders. The next thing is, if you just monitor power quality is not sufficient. You need to know what you want to measure actually, because all the power quality equipment comes with very large number of features, but depending on the site, depending on the customer, depending on the context, you need to identify important features to measure. So power quality monitoring is different from measurement. Anybody can do power quality monitoring. You can just connect the meter at any site. But measurement requires what parameter you need to measure, why you need to measure, how long you need to measure. After you measure, you should be in a position to verify whether the results, recorded are correct or not. This requires expertise. Not everybody who is supplying the equipment can do this, but there are people who can do it because they have experience. They have done at many places the power quality monitoring. So they understand whether the readings are correct or not, and they can correct. Okay. So power quality monitoring and measurement are first and second step. The third step is very, very important, is power quality analysis. Many equipment actually develop automatic report. That is not sufficient. Automatic report is actually used for regulator, because this report is prepared for some regulator saying that this particular site is actually within the harmonic. No, power quality analysis is nothing to do with just producing a report. Power quality analysis is comprehensive understanding of the problem, whether the particular site is having any problem or not. If there is a problem, what type of problem, why it is coming, what should be the remedial action, how to go about it. All this information will come if you do proper power quality analysis. This requires academic expertise. Okay, not only industry expertise, but academic expertise is also needed. Of course, I'm not ruling out industry. Industry people always should be there because any analysis on power quality it is done for some industry. Okay. So why do we need all these things? Power quality monitoring actually needs planning. It's not about just connecting a meter at one particular site at PCC for 1 week. That is what the standard says, not me. I will never say that you measure power quality for 1 week at any site, say everything is hunky-dory and good. No. So I have been in power quality standards in IEEE in 2001 and also in one voltage science committee in Europe between 2007 and 9. But remember, I'm observer only. The reason is, if you want to participate, you should do research and then share your results so that people validate your results and incorporate them in the standards as well as guidelines. Cannot just simply attend all these international technical committee meetings just to voice your concern without doing any homework. Okay. So anyway, the power quality audit is a part of this planning. If you are trying to do power quality planning, you have to start with power quality audit. Then if you are doing power quality audit at many places in a plant, then only power quality management comes. That means power quality management is a comprehensive way of looking at the power quality outside as well as inside the plant. Power quality is not restricted to only PCC. That is the poor understanding of the people, because initially power quality, everybody thought it's the responsibility of the grid. No, the harmonics are coming from the customers and the grid is concerned about these harmonics. So they have mentioned or they have came up with a policy to measure power quality at the PCC. But what about the rest of the power quality event? They are all coming. Some of them are coming from the transmission to the distribution system. Who will bother about that? Who is responsible for that? Who will try to mitigate that? So power quality is not only important for the regulator and the utilities, but it is also important for customers and various other stakeholders. Okay. Anyway, demand side PQM is there. And at the end of the day, you know all this standard. Not even IEC or anybody told you what you should do with this standard. You have to do PQ benchmarking. And PQ benchmarking is for utilities. And this PQ benchmarking is done in Europe since 2003. So the ultimate goal of doing all these things is to do benchmarking power supply quality. Remember, they are doing PQ benchmarking in 2003, 2004, 2005, and Math Poland was part of it. They are doing without all these guidelines that you have right now. So the guidelines IEC has developed on power quality management or demand side power quality management, all these things are coming from long research work done in the last 20 years by various people in from the power quality background and industry and academia. So if you see here, I'm attending a conference, IEEE TANCon in Chiang Mai, delivering a tutorial on power quality. So I have conducted a tutorial at IEEE TANCon. This is a very big conference in Region 10 Asia. Okay. And it was attended by many people. That was 20 years ago. I have conducted a workshop on power quality at international conference. Okay. You don't get an opportunity to conduct a workshop or a tutorial at IEEE TANCon unless you are an expert. Okay. And coming back to power quality in the smart grid, why actually IEC 63222 actually talking about power quality management? With the development of smart grid by many utilities, massive deployment of renewable energy is taking place. And power quality issue has received major attention from the system operators, customers, mainly because of the sensitive power quality loads, especially power electronics loads, but also the market regulators with the demand to provide information on actual power quality. So the market regulators, system operators, and customers are becoming more awareness of the power quality, and they are demanding the data. They are not asking questions, they are asking data. So power quality management of the grid is nothing but a big systematic project, which includes the whole process of planning, operation, assessment, and mitigation. So unless you do this meticulous planning, you will not be able to provide any data to anybody. Because if you are providing data to stakeholder, first you should understand the data and its importance to the stakeholder. Otherwise, it becomes a number. The characteristics of the power supplier, load characteristic, power consumer, external environment, all of them affect the power quality. And the key element in smart grid is to improve to the voltage quality as well as reliability. Security and sustainability are secondary and tertiary. Okay. So this document that we are going to discuss focus on whole process management and the guideline, general guideline related to power quality. Okay. So power quality is an important issue for electric supply network operators, which needs to be handled at planning and operation stages. Not everything is ready. So this kind of a definition, for whom is it important? It is important to state electricity regulator, central electricity regulator, utilities, especially the DISCOMs. All the DISCOM people should be attending this webinar. And they are to be lucky because they are attending. This is free of cost. Tell you, very important thing, all my previous presentation webinar, none of them are free. Okay, of course, if I'm giving a webinar to university students and research scholars, it is free, but otherwise none. Okay, so you can see here, okay, in order to achieve power quality target, reduce power quality impact and losses, and improve the economic efficiency of the system, power quality regulation and supervision of the operating power system is very necessary. And well-considered power quality planning before project implementation is also needed, such as system expansion, construction, and grid connection for the distributed generation. So power quality management is a method to avoid further power quality problems after project implementation. That means this particular new standard which is coming up, IGC TS 63222, okay, which is only technical specification, is important for all RE plants. Okay, now how many RE plant owners, operators know this particular standard and organized this webinar or discussed with the various stakeholders, including CEA or BIS or POSOCO or Grid India? Is it happening? I don't think so. Because you can see here already IEC TS voting is gone, comments deadline is gone, and we don't see any contribution coming from India or any Indian expertise. Forget about all IIT professors. Okay, I don't want to talk about them. Their contribution to these IEC standards is actually very, very poor. Anyway, coming back to power quality management guidelines, that is the introduction. Let me quickly go through this. As the general guideline of the standard series, this specification summarizes power quality indicators. What are all the indicators that you need to measure? How to measure, assessment methods, and analyze the overall power quality. How do you analyze the overall power quality when you have done monitoring study in a big plant from various locations? Okay, so by monitoring assessment and predicted assessment, it has two parts. I will explain you what is there in the two parts. So this guideline says that you have to measure the power quality and assess before and after. And first time you actually assess it, second time you should be doing prediction. Okay. So monitoring system and field tests are used to assess the power quality level at different nodes of the grid. Remember, here everything is mentioning grid. That means this is important for the grid operator. Okay. So that they will be able to handle any power quality complaints coming in the future. Okay. So that is the idea. Okay. So here I would like to highlight what is there in this part one. Part one has two parts. One is business use cases and also system use cases. These business use cases and system use cases form the part of power quality assessment. And business use cases means there are different stakeholders who have power quality business interests, how they should do it. And these business cases are developed by various experts from different countries. And I will show you only a few cases, use cases. But where are the use cases coming from any Indian expert or Indian industry or Indian regulator? Okay. Anyway, so here these are the business use case 1 and 2. So business use case 1, you can see the number is UC6322P001. What is the business use case here? Manage power quality over the grid. Okay. So it is a stakeholder related to the grid. What is the domain? Customer support, network operation, network and extension planning. So all the people who are in the transmission domain, they should participate and learn what is the importance of this particular business use case. The business use case describes the system operator main processes to manage power quality disturbances for the reliability of the power system and ensures continuity and quality of the electrical energy provided to the grid users and their connection point of the grid. So all this has to be done by Power Grid Corporation of India. Okay, now the business use case 2. Manage complaints on power quality over the network. This is associated with customer support, network operation, network extension and planning, same. So this is also related to the transmission guys. Okay, the business use cases describes the system operator main processes to resolve a power quality issue. How to resolve there is an issue. So these two use cases are addressing the importance of these use cases to grid operator. That's use case 3 and 4. Provide report on network power quality. Again, this is both are same. The business use case describes the system operator main process to retrieve, build, analyze power quality data and report on it for different commitments. Okay, so this is the last one. New user is connected to the grid, which can meet the power quality of load and the grid. So all the 4 use cases are actually addressing the needs of the grid operator to manage their power quality because of deterioration coming due to large integration of renewable energy. Now, India is very aggressive on renewable energy integration to the grid. And all power electronic experts across the world and in India, they are very aggressive in developing new power quality or power electronic product. But both of them are fully ignorant on power quality issue because both of them are not at all concerned about supply power quality because of the large integration of renewable energy. And there is to be a lot of homework missing. Actually, they can do RE integration, that's fine. Power electronic people can always develop new products, fine. But both of these people, they are not at all bothered about emissions coming from this renewable energy equipment. That is very concerning. Okay. Now, coming back to what are the business roles in the IEC TS 163221? Here, I just quickly go through this. It consists of different roles: system operator, complaints, B2 complaint, network operation, grid user, electricity supplier, conceding authority, regulator, grid user. So all these people have stake in this standard. Okay. The business use case actually develop to identify and responsibilities, the roles of each segment of this, power system. Okay. So you can see here, system operator, party responsible for safe and reliable operation of the part of electric power system in a certain area for connection to other parts of the electric system. Okay. So of course, there is a reference for particular standard. Similarly, grid user, come back to here. Party connected to the grid and consuming and are producing electricity. Grid users include consumers, producer, and prosumer. So let us say tomorrow we are actually encouraging prosumer, okay, who want to develop renewable energy from rooftop and also want to save this, store this energy in electric vehicle. Who is actually aware of this particular standard to follow the guideline and implement it? Now, many companies in India are actually developing and installing EV chargers. Some of them are actually went one step further and installed EV chargers in communities, okay, or public places. How many of them are actually doing a homework and a research and study to implement all these things in safe manner so that the emissions will not disturb the environment. Has anybody actually come across whether Tata Power or another company which is installing EV charger has done any research in India? What are the emissions coming from this fast charger, DC charger, AC charger? Or is there any IIT professor or any academia has done this? Okay, it is a very safe that you can install a EV charger in the commercial building or in a shopping mall or in a public place. No, you can see nowadays so many fires are coming due to electric vehicle. Of course, right now we have not seen any fire coming from EV charger, but only EV is coming. Okay, maybe in the EV it is due to battery. Again, we don't know what is the problem, whether it is a material problem or a power management problem or a manufacturing problem or the bad usage of the customer itself. We still don't know who is the culprit in this fire accidents which are coming due to electric vehicles. Okay. Anyway, so now other than business use cases, there is also a mention of system use cases. Here I just show you 3 system use cases which are mentioned in IEC 63222. The first one is, you can see here, they put system use case S001, previously BU, business use case. Okay. So system use case is about monitor power quality on the network. Okay. Brief discussion. This system use case describes the structure, composition, general workflow of power quality monitoring and functional requirement of each layer. Okay, next one, measure power quality on a specific point. How do you measure power quality in general? How do you measure power quality at a specific point? Then the next one is assess the emission limit related to power quality technical parameter power system. Remember, later I will be discussing one case study. We encountered this situation when we want to do a study. When we want to do a study, we are doing study to a third party which has no complaint to us, and we want to investigate the problem in a random forest. That means where we want to do power quality is may not be a right place because it's not coming from the customer. So when we have encountered such a situation, these are all the steps that you need to follow. First is generic. So when you do first time power quality monitoring, first you don't have any idea where to measure because the plant is very big. When the plant is very big, you are not doing power quality monitoring at PCC, but you are doing it somewhere inside the location. When you want to do somewhere inside the location, you have 100 points or 50 points or 10 points. Where do you start? You cannot measure at one place and then say everything is fine. So this is a systematic process, how you actually do. How do you identify general power quality and how do you identify specific power quality and how do you identify whether the emissions are there or exceeding the limit or not or within the limit. Okay. So these are all the use cases are developed thinking in if somebody is venturing into a new area without any guideline or expertise. If you have expertise, you don't need any guideline. People like me, we try to do the study, we don't need any guideline. We actually formulate our own guideline and we have a reason. Of course, our guideline or approach, it depends on the, the context and project and time that we have and the resources that we have. So we all plan all these things. So all these things will come into any standards or regulation when everybody shares all these things on a single platform and agree on certain common principles. Okay, common principle, common approaches, common method. So the standards are actually nothing but a consensus development of whole process. Okay, so this is a simple way to explain power quality management. Okay, I will explain the 2 things and I will go to case study. So power quality management has 2 processes. First process is assess the power quality in the current. Okay, how do you do it? You can see here. Okay, so in this block, what you see here, you have power quality monitoring and you are doing field test. Okay, and then the purpose of this is to do a routine. That means you are not doing one time. You have to do routine. That means first you assess if there is any problem. What is the economic assessment? Is there any improvement required? if it's required, you have to identify what is the solution. And again, you have to see whether power quality is improving or not. Now, this loop can start if there is a complaint. If somebody complains there is a power quality problem, again, this loop starts. Okay. So remember, when there is no problem, you will publish report. When there is a problem, also you will publish the report. So now this whole process is executed 365 days. Okay. So to get existing PQ level. Now, how do you do this? How do you do this? It is mentioned in business use case 2. And how do you do power quality management? This is mentioned in business use case 1. Okay. And how do you share this data? This is mentioned in system use case 1. So power quality, it is mentioned as a 2 steps here. One is present, another is future. That means this present future cycle, it repeats. That means if power quality become a continuous process, then only you will be able to do the management. You cannot manage unless you are doing continuous monitoring. Continuous monitoring means it is not measuring power quality for 1 week at a particular site as per some IEEE 519. Okay. You have to understand IEEE 519 was developed in 1992. We are in 2024. Okay. So many people may be using IEEE 519 or all these things only recently. I have been using all these power quality standards since I started doing research on this topic since 1998. Okay, so how do you do the same thing in future? That means after you complete the present power quality assessment, then what you need to do is you have to assess the power quality for future planning. Okay. Again, in the future planning, the block diagram is very same, but you can see here there is a background analysis. In the background analysis, monitoring is there, field tests are there, and that output, what is the impact? This impact has assessment. In this assessment, again, the blocks are same. Economic assessment, what is the power quality improvement required? Now, improvement required depends on what kind of mitigation solution. Okay. And you publish that here and you give this back to the original. Okay. So now this whole process, which is highlighted in blue, is given in business use case 4. Take into account power quality constraints in the connecting a user to the grid. So this whole process is required before you connect a large wind energy into the grid or large solar energy plant into the grid. Okay. And here this report, again, it is going into the business use case 3. What is this? Provide reports on network power quality. That means all the 4 business use cases, all the 3 system use cases, they all work together to provide the power quality of the network for whom the various stakeholders and the maybe companies like Power Grid, they should share this information with Grid India, which is a POSOCO, and also the stakeholder, which are RE customers. RE customers are RE owners who are integrating their plant into the grid. Okay, so they also should be familiar with this whole process. Okay, now let me conclude with this with power quality assessment. On the monitoring, you actually have 7 steps. First is object and range determination. Second, system and equipment data collection. Third, monitoring plan formulation. Fourth, testing data obtaining. Fifth, data analysis. And 6th, you may have any suggestions based on the work done, whether you have a solution for that particular problem, and mention that in the report. Then next, what is that you need to do in the future? What is the object and range determination, system and equipment data collection? Now you have to assess the prediction, okay? Assessment under the prediction. You have to predict any power quality issue and act before it happens. That is the idea of this power quality management. So whatever the past data is not just for publishing on internet or in a report. You have to use the data to predict the power quality in any context, in any site, in any customer, and take action before, not after. Okay. So power quality, this is considered advanced power quality. Now tell me, advanced power quality will not happen if people are not able to use their expertise continuously to the domain. Okay. So people who are having expertise in this domain, they should not only do monitor and analysis and offer solution, but they should be able to help in planning and managing power quality at the next level, especially grid level. Now, coming back to the case study. So this was a case study done in Europe in 2012, very long time ago. You know, in a particular solar power plant, continuously the transformer is failing. You know, you can see here, a large solar plant in Europe has experienced more than 20 solar photovoltaic transformer failures in less than 6 months. That's a big problem. In 20 transformer failuring in a in a 6 month period is problem, severe problem. Recently in Canada also 250 transformer burned, and many places also same thing happened, but that's the reason is different. Now, what is the reason? They conducted a study and found that switching transients are the reason. You can see so many transient, and here also they are identified that slow front current transient are not severe, and amplitude with negligible effect and sort of the kind of events happen many times every day during morning just after sunrise. Okay, so they mentioned that switching transients are major. This kind of events happen almost every day at every time. Okay, so these switching transients are very. In fact, when we did the study, we also found the same thing. I will share our study, but remember, we came across this paper halfway during our study. That means before we could look into this paper, we already have similar information coming from our study. Okay. So anyway, I will come back to this particular slide later. You can see here what is happening at SPV plant. A lot of transformers are failing. Of course, solar photovoltaic transformers are different from distribution transformers. Okay. But this problem is not only happening in India, it is happening in EU, and then you can see the previous paper where it was mentioned 2012. That means the paper was published in 2012, but the thing is happening before that. Okay. And the reason for doing that study is to identify what is the problem and find the solution. Okay. Now, here this is the one case study. This thing happened in India. We don't know exactly the reason because we don't have any data. We only have pictures. Okay. Now, this is another problem where the cable, photovoltaic solar plant cables caught in fire. And because of this, the plant was not running at all. And they are not able to fix the problem also. Again, we don't have full details because they don't want to share. They don't want to share, they don't want to fix the problem, they don't know how to do it also. This is the current situation in India. Okay? People do only just project commissioning based on their associate and counterpart, but they are very slow in solving problem or studying the problem or investigate the problem, and more importantly that they are not ready to share information with anybody. Okay, so if they don't share any information with anybody, nobody can help them. That's another thing. Okay, now our study, we have done two types of study here. First, we have done equipment failure survey. So our idea is to investigate where there any inverter duty transformer or solar photovoltaic transformers are failed. When we conducted this study, you can see here inverter duty failure. How many of the people said yes? Only 3 out of 13 plants. Now, if you look at other cable failure, again 3, IGBT PC 1, VCB failure 2, okay, and inverter faults 3. So if you see PQ audit, whether they have done PQ audit, only half of them said PQ audit is done. And if you see the plant age, some of them are old, some of them are new. Actually, many of them are old, only couple of them are new. Okay. Now you can see all the plants are in megawatt. Only 2-3 plants are less than 10 megawatt, remaining are more than 10 megawatt. And you can see one is 200 megawatt, another is 50 megawatt. Now, the site study, out of all the 13 plants, we are able to do site study on only 3 places. The rest of the people, they are not interested in this site study. They are able to provide at least this information as we approached them personally. Okay. So now what happens is, it's not about only inverter duty transformer failure. Inverter faults are there, cable failures are there. IGBT, PCB failures are there, VCB failures are there. In fact, VCB failure is the biggest problem. Okay. Just like the previous article mentioned, a lot of transients are happening. All those transients are coming due to VCB switching as well as inverter switching, both. Now, the summary of our survey tells that all the equipment are having similar number of failure. You can see 3, 3, 3, 2, 2. Okay. Peak audit is done. Okay, peak audit is not done at 2 places. 7 people have done site visit. Okay, leave it. This is summary of our survey. We have also done power quality monitoring at a couple of sites, as I mentioned in the previous slide. So you can see this event. Many people think this is a voltage. Some people think this as a voltage transient, but these are occurring together. So when you have power quality events occurring simultaneously, then the problem is more severe. Okay. So you have to understand that not single person has done the effect of multiple event on the equipment performance until today. 2004 in Tancon, Chiang Mai, we published a paper studying multiple PQ events also. Okay. But since then, hundreds of people have done PhD, but nobody addressed any new problem. Okay. Even if anybody has to address this problem, new problem, it has to be only by me. Okay. So here I would like to highlight this type of transient you will not see in any IEC standard or IEEE standard or even national standard. Why they have not mentioned this type of a disturbance which is occurring regularly and analyze what should be the way to mitigate, because this is natural. Whenever there is a fault, there is a sag. Whenever the circuit breaker opens and closes reclosure, definitely you will have transients also. So transient and sag will come. If harmonics are also there, it will be another like a salt on the wound. So all these things will come together and which nobody investigating. That is the reason there is a failure, because when multiple events happen on any installation or any equipment, the failure rate goes high. Okay. Now here the summary of our power quality audit. You can see here when we monitored power quality for 1 week, we have dips and we have voltage variation. We be slow or fast. We have swells. But look at transient. Every day, these so many transients are happening. You can see positive, negative. Every day. You want to know that you can see the date also. But remember, they are not doing any failure. But remember, these transients are going to create stress on the insulation. So if you look at this table, out of all the power quality event, and of course, report only identified 13 transients which are as per the limit exceedation. Okay. But remember, otherwise the transients are around 9,000 and 9,000 on one phase and 200 on B phase, 102 on C phase. So when you see that one particular phase is having so many transients, definitely something is bound to happen in that particular phase, because it's not happening evenly on all each phases. But if you look at only power quality report, okay, you will only see small. In fact, this particular table, it shows 2 power quality meter. One is Fluke 434, one is 177. One is on the LV side and one on the HV side. We are also trying to show that the HV side or this is the event, the LV side or this is the event. So LV side of the inverter, you will see so many, and HV side, you will only see very small. So you have to understand, if you just monitor power quality at PCC, only you are just measuring there only for harmonic. That's it, nothing else. Okay. So I would like to conclude my presentation with the last slide, that you can see here me presenting power quality workshop at IEEE Tancon in Chiang Mai in 2004 November. Okay, 20 years ago. And this is one of the power quality sag generator equipment, and some of my participation in international events and Singapore. This is one of the smart cities event in Bangalore. And of course, even in smart cities event in Bangalore, I was talking about 2 things. One is the importance of power quality, and second thing is the data centers. And power quality is also very important for data centers. Okay. So with that, I would like to conclude. If anybody has any question, you can put it in chat box, question answers box. Okay, or you can write to me also. Okay, so that's all from my side.
Thank you, Dr. Chilkuri. Thank you for wonderful presentation, very enlightening, and I'm sure I'm getting a lot of congratulatory messages from people for presenting a very nice, very informative topic that you took up. So I'll pick up few questions. So we are now almost 1 hour, 5 minutes now. So we'll take 15 minutes question answer on that. So I will anonymous. I am not going to touch because there's no name. If anybody want to put up a question, please make sure that your name is mentioned. Anonymous, we don't know who are you and from where you are addressing. So I will straight away go to Soumyajit Chaudhary. Asking, we have implemented the installation of harmonic measurement through HT relays, SCADA networks in substation of SAIL using ESM Rayroll Schneider products. So I think what they're saying is they have implemented harmonic measurement through HT relays on SCADA. So that is not a question that they're asking. They're only saying that we have done. So Kaustubh Patil asking, what are the network scenario which causes the power quality events which are shown in this signature? Can you answer that?
Well, yeah, I think you might have seen the waveform. That is actually a fault on a one particular phase. When you have a fault on one particular phase, during the fault, you will see a sag. If the sag is appearing on a 220 kV line, it will go downstream. So that means you will see the sag on 132 kV, 33 kV, 11 kV, and the customer. So the sag will propagate from higher voltage to lower voltage. And remember, the sag duration and width will change while it is moving across various transformers. This particular study was done by Matt Boland in, I think, 2007, that LG sag will translate into two-phase sag or three-phase sag when it is changing from star delta to delta delta to star transformer. So that is why a company like Intel, if it is connected to 66 kV, and if they are experiencing a lot of voltage sag or transient, okay, due to lightning in Malaysia, you know what they did? They have two options, whether they can install DVR, which can protect from lightning and sag, which is very expensive, or they can actually upgrade their intake. So if they move from 66 kV to 132 kV, 66 kV network is very huge compared to 132 kV. So when you move to 132 kV or 220 kV network as an incoming, you have less probability of getting this voltage disturbances from the transmission system to the customer. So this is a very simple solution and a known answer to me. And yeah, sag, harmonics, they propagate from transmission to the distribution.
So can you unshare the screen? Can you unshare the screen?
Unshare.
Yeah.
It is a new share.
No.
Unshare.
Yeah, you can unshare. Go to the share, go there, unshare because your screen still on sharing.
Stop sharing. Done. Good.
Now,
thank you.
Okay. Now I'll take the next question from Jayant Sharma. In your initial slide, you stated harmonics are corruption of voltage supply. Voltage harmonics are resultant of current harmonics. Is only voltage harmonics part of power quality?
Okay, I will clarify first the point. I did not say I did not say what is the question. Can you repeat that?
I'll repeat again. In your slide, in your initial slide, you stated harmonics are corruption of voltage supply.
No. Actually, yeah. I did not say harmonic. I said power quality. Power quality is the corruption of voltage supply. Okay. That is what power quality is the general term. Harmonic is only one part of it. And harmonic, who are responsible? Mainly customer. Okay. But if the customer is not doing any mitigation, harmonics are the one problem. Normally, customer produces only current harmonic. Okay. Now, these current harmonics are coming from the system through system impedance. So what happens is the current harmonics propagate upward. So when they propagate upward, they will impact neighborhood also. Now the question is, do you think that only customers are supplying harmonic? No, wind generation produces flicker. Is it wind generation is a customer? No, wind generation is a utility. It's a private or public, it could be anything. So what happens is, harmonic will move upward and downward. Okay, they will go anywhere. Okay, so majority you have to take care of the customer, but you need to have responsibility on the grid operator also. Okay, so the grid operator has to know his limits and his constraints and his responsibility. Customer also has to know his responsibility, his limits and his constraint. Everybody has to act together.
Okay. Next, Mr. Radhaswamy from Bangalore is a member of, is an active CWC member, NFE Bangalore. So he's asking, good morning, sir. I'm Radhaswamy from Indian Institute of Science. Sometime back, we had an issue of a wave peak distortion where many of the power supply units of research equipment have gone bad and very difficult to claim insurance. And we could not do anything for a peak distortion. I just wanted to know any advice and solution or peak distortion. Please advise.
Sir, I will tell you this importance of monitoring from both customer point of view and also insurer point of view. As I said, when I was conducting workshop or seminar earlier, I was paid actually. And when I was in Malaysia, all my participants, they are not every time from electricity industry. I was surprised. Insurance people are attending my training on arc flash and protection. And I asked, in fact, one of the participants was my student, sibling. So she told that they are gaining knowledge so that they actually provide insurance to utilities. Now, it is the responsibility of the customer to do continuous monitoring for two reasons. For one, their own equipment, asset monitoring, health monitoring, and reliable operation of their plant. That is one thing. If you monitor, it is going for your own good. Second thing is, when you are monitoring, if there is an issue or equipment failure which is due to the responsibility of the utility, you have the proof. Unless you have a proof, okay, you cannot go to insurance or you cannot go to any court in India to get a justice. Okay, that means you cannot look for a power quality expert or power quality monitoring equipment after you have encountered damage. You have to do before. So if you continuously monitor your own network power quality, then you have chance to go after insurance or utility also. Utility also, you can blame them and file a case against them.
There are individuals who are putting multiple questions. So those who have multiple questions to Dr. Chilukuri, please, there's an email, Ms. Lakshmi, the backend, she will put the email ID of ours. So we will forward it to Dr. Chilukuri. He will reply to you if you have more than one. So there are so many questions. I'm going to pick up. Everybody should get fair chance. So I'm going to the next question from our chapter president of Mumbai, NFE, Baveja sir. Is asking you, with every passing day, the complexity factor is increasing, and how to take care of this aspect in power supply system locally and grid level and national grid level.
Sir, this is a very important question. And what we can do as NFE as well as an individual also is that three people have to come. One is me, I'm ready to come anytime. Okay. Another is CEA and Grid India, because Grid India take care of the transmission system, okay, especially RE integration to the system. But CEA is the regulatory body which can tell something to state regulatory authorities, okay. So the state regulatory authorities, CEA and Grid India, and if BIS is interested, BIS can sponsor this event. First, you have to spread awareness that the need for monitoring power quality. Okay. And our friends, the OEM, the power quality monitoring equipment supplier, they can also participate and they can put their hand and say that we have this equipment, you can buy whatever you want. Continuous monitoring is needed. Why I'm telling you, we have not learned the importance of two things. One is PPE and another is continuous monitoring until COVID hit. Until COVID hit, nobody is bothered about heart rate or O2 measurement. Okay. I was having two smartwatches 10 years before even COVID arrived, actually. Okay. And so what I'm saying is this COVID also highlighted the need of PPE. PPE word people don't know earlier. And PPE is only restricted to people who are working in arc flash hazard zone only. So my suggestion is that by 2030, we should have a clear-cut roadmap for power quality. Why? The reason is by 2030, we're going to have a lot of renewable energy into the system, and we will be having a lot of smart appliances, 5G or 6G maybe also coming. We will be having more problem with power quality in 2030 than now. Okay, especially the data centers, all these things. So I think this is the right time to spread, just NFE spreading on electrical safety, we have to spread awareness on power quality. Power quality, safety, condition monitoring, these are all in one by one. Safety is first, next power quality, then asset monitoring. So these three are there, then you can actually think about any smart grid or smart city.
Okay, move to next question, sir. Tarada, how a grid interactive solar power plant be effective without power quality monitoring? I repeat, how a grid interactive solar power
I understood
plant.
I understood the question. Grid interactive solar plant, it has nothing to do with power quality. Okay. So the grid interactive solar plant, actually, I think it is facilitating maybe the reactive power management resisted with the power, the renewable energy plant. But remember, that's not the only aspect of power quality. Power quality has many parameters, and these parameters, it's not X and Y are responsible, because sometimes X is okay and Y is also okay, but an X and Y interaction is not okay. That is the reason I told that who told that power quality has to be done only 1 week? Because when you are monitoring power quality only for 1 week at any solar plant or wind plant, where do you catch any interaction that is happening between grid and the solar plant or wind energy plant at remaining period? You leave 360 days and you just measure for 5 days. You cannot think that 360 days everything will be fine based on the 5 days measurement or 10 days measurement. So it has to be continuous monitoring, and I recommended this to Grid India just orally when I attended their presentation on major grid disturbances. In fact, they mentioned major grid disturbances due to one large RE plant in Gujarat or Rajasthan. So they are trying to struggle why this happened. Now they don't have meters to investigate. So I suggest you should first have meters, then you have data, then you can see where the problem is coming, who is the responsible. Everybody should know about the problem, not only Grid India or grid controller, because customer also should know.
Okay, we need to there are a lot of questions, so we need to quickly answer it in crisp and take the other. So Rahul is asking a little more technical question. I'll read out very slowly. We can probably pick up the power quality problem due to cable capacitance. How can we avoid for 11 kVA or 4.1 voltage distribution system where we need to connect the active harmonic filters or compensators? Is it ST side or a low voltage side? What will be the best practice?
See, the first question is, when you mentioned power quality problem due to cable, what type of power quality problem? Normally, cable, if you are connecting on LT side, you only see over voltage. Okay. So over voltage is not a power quality problem. Okay. Any problem which is only short duration is actually a power quality issue. If something is coming permanently, means you have to find some compensation for that. Okay. So that is my solution. If you want to define as a power quality problem, you have to first monitor and identify what type of power quality problem is coming to the cable connection.
Okay, Rahul, I hope that answers your questions. So Pradeep Mani, if we have sophisticated simulation software and based on OEM information on equipment harmonic generation, can we plan the mitigation design planned the design plan itself? Am I correct, or how the approach should be?
Yeah, actually it is good. That is what actually this power quality management talks about it. If you have information, the information sometimes you can actually get it from your own simulation study. Sometimes you can get it from the literature also. Already somebody has done that, and it may be in the standard. So based on the somebody's experience or your own simulation, you can always plan a mitigation. But remember, when you are actually implementing it at the planning stage itself, you have to also do verification. If you don't verify whether you are able to predict exactly like what is happening, because what we think in the beginning and what it translates into reality is there is a huge difference. Only in India, but other places, most of the time, if the road they think this is like this in the in the blueprint, the road laying also will be same. With in our cases, it's not happening in every segment, so we have to do verification also.
Okay, Anup Kumar Yadav is asking too much of it. Like, you want to ask, what is the IEEE on 5.1 standard THC? So what I suggest is, Anup, I will be forwarding your question to Dr. Chilikuri. Almost all the question will be forwarded to him with your contact details and email ID. He will probably answer you in detail later. So I'll just pick up few because we have two more. So we have one more webinar lined up. So I'm just hurrying up. So I'll take Hariba. There is a question from uh, Haribala, who was also our earlier speaker. Uh, when voltage transient occurs, the standard prescribes limits. How do we conclude the transient which are within limits as per standards are not harmful to the system?
Actually, my answer to this is, first of all, when you measure transients, okay, and this transient, as we mentioned in our previous slide, it is different on the LT side and HT side. Okay, so same phenomena, it is showing different information on the LT and HT. Now, on the LT side and HT side, we have different equipment. Okay, so these transients, if they are within the limit, sometimes nothing will happen to the insulation. But if the transients are occurring very frequently, and remember, transient will not be same every time. It depends on the context at the switching instant. That is the reason when the switching instance is the peak, PCB switching is taking place at the peak voltage, PCB will damage. Okay, so failures are occurring when there is a maximum worst scenario. So if you observe large number of transient in any network, you have to be very careful. You have to tell that it will affect the insulation over a period of time. That is the reason in some plants you can see that IGBT boards are damaged. What is the reason for IGBT board? It's not happening in every plant, but it's happening in some plant. And all the customers are okay saying that, okay, we have 1 year warranty, so we are getting replacement. But remember, not everybody is replacing things within warranty period, especially that IDT transformer. They are not replacing even within the, warranty period. Even if it is damaged under warranty period in India, people are refusing to replace. And they are blaming Harmonic, which I don't agree.
Okay, let's go to Balamurli B. Is saying, in your case study, the Fluke 1777 data summary shown more than 9,000 transient, whereas other phases show much less. What may be the possible reason for this in a three-phase system?
Very simple. We are actually one side, we are measuring on the inverter duty transformer, which is inside the solar plant. Okay. Now this inverter duty transformer, one side is inverter. Okay, 415 supply, three phase. The other side is 11 kV. Okay. So the 11 kV side we have measured using 434 Fluke. And on the inverter side, we measured using the latest. The reason is our initial presumption is that inverters are producing very high frequency harmonic called supra harmonic. So we want to use a meter which can measure this high frequency harmonic on the LV side. So we use PQ177, that is a latest power quality meter from Blue, can measure up to 30 kilohertz. Now, the very large number of transient on the LV side is due to inverter switching. Okay. Now, it is okay. During the period, we have monitored so many transients, but nothing is happening. But what I'm saying is that the transient's magnitude will not be same every time. So when there is an exceeding of the particular transient magnitude, peak magnitude, it can damage any component. On the 11 kV side, the transformer is there, isolation is there. So it will not pick anything. You know, that the transients which are happening on the LV side will not come on the HV side. You have to understand that. Because there is a capacitance is there, isolation is there, voltage is different. So that's the thing. You have to know voice.
Oh, sorry. Jayant Sharma is continuing to his question that you asked and you answered. He says, are voltage harmonics only responsible for power quality? The question is it voltage harmonics only responsible for quality?
Oh, sir, okay, I will tell you one thing here. Every load actually draws harmonic current, and this harmonic current not only responsible for voltage distortion, but also the impedance. I multiplied by impedance will create voltage distortion. Voltage distortion is only very, very important for equipment. Which equipment? Electronic equipment only. Electronic equipment is the only one which is drawing nonlinear current, and it is the only device that also get affected. So the problem is in electronic equipment, then effect also in electronic equipment. Voltage distortion is only people are interested. That is why the limits for voltage and current harmonics are different in any IEEE standard. Somebody mentioned IEEE 519. IEEE 519 is about power quality standard. It was developed in long time ago. If you see current harmonic, the limits are very high. Voltage harmonic very low. Why? Current harmonic will not create any problem. Voltage distortion only will create problem to sensitive devices. So sensitive devices, they should have their own built-in protection, or they should have overall protection from harmonic, like filter, passive or active filter. That's the only solution.
Okay, I'll take the last two questions, 25. Mohit Prashar is asking, as mentioned in the above slide, for the future PQ planning, is it necessary that there were business use cases of 3 and 4, but in present PQ planning, we generate report that was in the scope of BUC3?
So the last, what is the last point?
But in the present BQ planning, we generate report that was in the scope of BUC3.
No, what I say is that actually this business use cases 4 and then system use cases 3, they are given how you implement present to future assessment and present and future power quality assessment. Okay. So now this is only for grid operator it is given, not for discom. Okay. So discom side, people have to come up with similar solution, whether somebody is asking question from the discom point of view or from the grid operator, because the grid operator has a big network, and when he want to do any power quality study, he has to do systematically, and he has to do continuously also. He cannot simply do study and then stop. This is what happened in India. The power grid, they conducted power quality monitoring on their substation in 2017 or something like that. I have a report. They conducted the study 1 year and published the report. What happened after that? Power quality is not for one week or one year monitoring. They have to continuously monitor. If they have already installed power quality monitoring instrument on their substation, why they are not doing continuous monitoring every year and reporting? You have to ask this question to Power Grid and CEA.
Okay, I'll take Tipa Batla Ramakrishna is asking, there will be difficulty in predicting levels of harmonics at project design stage. How do we address this issue?
Sir, I think this is not difficult because when you are designing, you know what is the equipment that you are using in your plant. Okay. And all this equipment, they are already coming with their harmonic limits as per the OEM. OEM already telling that this equipment is well within the harmonic prescribed IEEE 519 prescribed limit. They say, but who is measuring? Nobody is measuring. That is why academy, they will always verify everything. You cannot take any data for granted. So what happens is, okay, this equipment produces harmonics within the limit. Okay, if the system, everything is perfect, but in reality, system is not perfect. So there will be deviations. So now what we need to do is when we predict or do analysis before planning, during planning stage, we have to consider whether deviations will keep us within the limit or exceed the limit. So it can be done, but it needs experience and data. It can be done.
Yeah, just update on our next program. So we have a panel discussion on CA regulation. So we are going to talk about panel discussion on update and implication of CA, MSES regulation 2023 on electrical safety. So this will be on 24th August at 11 a.m. Mr. Apavu sir and Gopa sir will be there. So it will be a panel discussion. So I think there are many more questions in the chat box. So what we do, we'll compile everything and we will give it to Dr. Chilukuri. And whenever he finds, he's a very busy man, he travels up and down from Vellore to Chennai, Chennai to Hyderabad, all over the country to rep. So whenever he finds time, I'm sure he'll get back to you. And we will have a couple of more series on harmonics, which is a very important power quality. Again, as we introduce new webinar, the kind of questions that comes, we always feel each subject need a series of series 1, series 2, series 3. So as I said in the beginning, every month we do 4 to 5 webinars, various subject. Okay, this your participation is kind of testimonial that our webinars are liked by many and is very technical, less of commercial interest, and we do not entertain any product promotion during the webinar. So that's the reason we continue to have 400 to 500 participants in each. Whereas you look at any other topic by any other society, we get only 30 to 40 participants, whereas we get 300 to 400, which means we are hungry for information, hungry for knowledge, hungry for to bring the change. So it's a positive sign. So I want to thank our speaker, Dr. Chilukuri, for coming forward. And we have many more experts on many other subjects. We'll keep introducing them as we introduced today. And please do join in our next webinar. Tomorrow we have different subject. How is our future shaping up? We are talking about project management. How do we construction management talking? So that is at 11 o'clock tomorrow. Again, we are doing Saturday, Sunday. We have no breaks. So knowledge is something that we love to share with people. So I want to thank again to all the participants who joined us and being patiently listening. And this video of Dr. Chilukuri of his presentation will be made available in our NFE website. So I would urge everyone to become a member of NFE, strengthen it. We have now crossed 1,500. We expect to complete 2,000 members by October. And you can meet all these expertise like Dr. Chilukuri, interact with them, gain knowledge, and find solution to your problems. So you have a wonderful week. Enjoy with your family with the weekend, and we see you again as soon as possible. And maybe the next session, next Saturday, we'll see you. Thank you, sir. Thank you once again. Thank you, Lakshmi. Thank you, Navya, for supporting from the back end. Thank you, Gopakumar, sir, who came in and just left now. So we look forward to see you again. Thank you. Bye-bye. Have a wonderful weekend.